Thanks a lot, and wonderful to be here. I also enjoy Thailand quite a lot, and you see me without crutches now. I can tell you crutches are great to go through the airport very quickly. So today I'm going to talk about open source software for kinetic modeling, and my in some sense disclaimer is that we don't really have any of ourselves. We have in-house stuff, but we don't have any open source. There's a tiny little bit in stir, but you can probably better ignore that. So that maybe gives me a little bit impartial view on whatever is out there. So I thought it would be most useful to give some definitions maybe and licenses, and then sort of discuss what are the challenges and how do you do this. Then a little bit of an overview on what's out there on kinetic modeling, and I'll end with a conclusion. So there is a lot of work on open source, and the open source initiative is a good place to start. And they have these two quotes here. It's a development method for software, obviously, that harnesses the power of distributed peer review and transparency of process. So it's open, but it also, and that allows other people to check your code, which is great and scary. But that gives you then higher quality and more reliability. So that's in the end what it was already mentioned. You have one person working on a bit of software and it works, but then you give it to the next person and it no longer works, right? So you want to do this in some kind of collaboration. So there's quite a few of different licenses out there. So there's obviously commercial packages around, but talking about open source, and they range from the very permissive, which more or less says you can do whatever you like, to the very restrictive while still being open source. And I'm not going to go through all of this, but so the bottom ones are sort of called viral. If you use this, everything needs to be like that, and the top ones essentially say, yeah, we don't give you any warranty, but aside from that, you're fine. So what are the benefits from open source in a research context? Sorry. Obviously, a community effort can accelerate research, although I have to say that the time that you invest in the open source sort of sometimes slows it down as well. So there's always a balance. You give other people the opportunity to use your software and also check your software, which is very useful in many cases. Obviously, if stuff that you want to do is not out there, then you can implement it using these things. But how do you go about and do it then? Well, first of all, you need to make that decision. I'm going to make it available to others. And then you need to start to think, actually, can you do this? Do you own the copyright? And that's not an easy question. Are your students, do they own the copyright? Or is it the university? Or is it your funder? Those are all questions you need to raise. And then which license are you going to use? And that's often a discussion with whoever owns the copyright, obviously. But then you make it open source, and there's not much, use in some sense to put it out there if other people are not using it, right? So you want to get other people interested. And that means investing time in that. You need to get your website up and whatever. And these days, it does mean putting your code on GitHub or GitLab or SourceForge, or there are a few others of these things, so that people can discover it there and see what's going on. And that then allows you to incorporate other people's contributions, because that's the most useful thing, really. We don't develop this code stuff for ourselves. We want to be able to benefit from other people's work. That means you need to think about how do you do that. And usually that means having some contributor license agreement. People need to agree that they need to agree to the license that you want to distribute your stuff on. And our university, for instance, insists that this is a signature then. You also need to think about versioning, including other people's code. Means you need to do something like Git or whatever version management system. And then that means you also need to have testing, because you don't know if their code will work, or you actually don't know if your own code does work, to be honest. And then how do you put all of that stuff together? So once you have all of that, then you need to start to think about deployment. So how just putting the code out there is not enough. You need to be able to make this easy for people, right? And that means it also needs to survive. And doing that means you need to think about the long term. And that Rich already mentioned, you want to have versions of when do you run stuff, which version of the software did you use for your analysis, but actually you want to be able to reuse that software 10 years later, yes? And that's not easy either. So there are some solutions for this. You need to have what's called regression testing, so you make new versions. Are you still giving the same result? If you're not, do you know that you're not having the same result, and is it a good reason or not? Ideally, you set this up in some kind of continuous integration platform. All these GitHub and all those things, they have that for you. You can automate it, and every change that you make, these tests are being run. Mentioned already version management for your own software, but you actually need to also manage the versions of whatever you depend on. Yes, and that could be, I don't know, could be PyTorch, or it could be some tool to read DICOM files or whatever. These things move on, and you need to catch up in some sense, and you need to know which versions are do you need to be able to run this. And that means in the end you probably need something like Conda or whatever to track those versions and to install them together with your own software. An alternative to that maybe to Conda is what's called containerization. So you can have virtual machines or Docker instances or Singularity instances that you package your software up, and you say people download this container and it will work because it's sort of isolated. Recently found out that even then it can fail, but nevertheless, most of the time it's okay. So, okay, but what kind of challenges are there in this process then? Well, you have sustainability issues, yes. I mentioned a lot of those already. You need to be able to test, and therefore you need to have the data to test it. And you need to be able to have your contributions in a sustainable way incorporated. It's not just fitting your time activity curve, right? You need everything around it. You need segmentations, you need visualization, you need databases, you need storing, version tracking, and whatever. And soon it starts to grow and grow and grow and becomes maybe unmanageable. So good software design is crucial, and you need to probably think a little bit in advance, and then you need to learn, because after a while you always discover that whatever you did was not good enough, and you need to refactor, as it's called. If you're going to put out there, a comment that you often get is that there is not enough documentation. And then it turns out that there is too much documentation because people don't read it anyway. So you need to find a balance there. And how to write good documentation it's an art, really, and I don't master it. So, you need to keep up with whatever is happening around you. Software evolves all the time. You say, I'm running this on Linux, but Linux moves on, and you need to be able to see, can I still run my stuff in new versions? And you need to keep up with the science, yes? Methods do move. You have that out there, but then you need to be able to manage your user expectations. It's not going to be everything they want, right? You need to tell them, this is only what the stuff that I can do, or we can do, and hopefully that's useful. But you need to get them involved. You need to manage that in some sense. You need to make sure that there are other people interested in your software, and that is hard work as well, because after a while, the interest disappears because somebody else comes up with an even better package, or I shouldn't say even, a better package. And then the actual contributors is usually a small group of people. If you write image reconstruction software, you need to talk to your vendor usually, and if you write direct parametric reconstruction software, you do need to do that as well. And clearly, there's a lot of time. Okay. So what is there out there for kinetic modeling? So what I try to do is I look at a research paper from Wabao, Arman and Roger, and they have a list of commercial and software, and they have a nice table in there. Nicholas Karakatsanis has a nice website where that sort of, if you have new tools, send it to him, and he will add it on there as well. And then there was some recent feedback that uncovered some other things that we didn't know about. And then I looked at only the open source or free packages, and I looked at what was available there, not as far as features or test data or sustainable software practices, because I couldn't do that really. But do they follow open source criteria in some sense? So, and then the list becomes a little bit smaller. So I've categorized this subjectively in sort of the, let's say, most open source philosophy type of bits of software. So you see them over here. I've listed license. Most of them are permissive, some of them are not. A lot of Python and MATLAB stuff, and a little bit of C++. And then you see that most of these actually are quite small efforts, right? Except the two bottom ones that are integrated into two large, very large projects, MIT'23 and FreeServer, as lots of different tools in there, and PetServer is one of them. So it's a bit hard for me to guess how many contributors are actually working on the kinetic modeling part. But the advantage of those is that you have all the segmentation and whatever stuff around it as well. Some of the others have that as well, but then implemented in, for instance, in MATLAB or so. Then I looked at some others which are very good packages as far as I know, and also the papers are very good, but you either see that there is one contributor here which feels a little bit scary, because if that person retires, you're in trouble, or they haven't really stated what license they have, and that is a problem, because then you don't know what you can do with it really. Yeah, and then I have some others which are listed there, which I think essentially don't qualify for open source anymore, but maybe they could be made open source. Yes, because maybe they don't even give you the source at all. They just give you an executable, or it's they explicitly say, well, you can have the source, but you can't give it to anybody else. You have to go via us all the time, which is not really part of the philosophy in some sense. That doesn't mean that these packages are not good, right, or that they are not useful. Some of these offer things that none of the others offer, but they are not really open source. Okay, so time for me to conclude. Open source software, I think, is great, has a lot of promise, but it's probably a bit harder than you hope to do that well. So it takes time. So there's lots of software already out there for kinetic modeling. Which one you choose, it's up to you, and you need to think about licensing. Obviously, features. Does it run on Python or MATLAB or whatever that you want to run it to? And I think kind of important, is it going to survive your studies, or not just the one study that you're doing, but your whole research career in a way. I encourage very much for people who write software to look at the Software Sustainability Institute. It's a UK institution, but they have connections with lots of others, and they have lots of very good advice on there. Do we need other open source software for kinetic modeling? I think you probably want to think a little bit about this. Obviously, there are specific requirements that the others might not do. Maybe you implement something that others haven't yet on another platform, or you want to combine it with reconstruction in some sense, or the license is not compatible with whatever you want to do. But otherwise, maybe you want to think, okay, there is something else out there already, maybe we team up, yes? And that might be good, because I think the kinetic modeling packages are a little bit small in a way. On the other hand, I always get frustrated if people say, oh, I developed my own image reconstruction software. And I say, why? Because we have this stuff already out there. But competition is good, as any capitalist will tell you. So, yeah. Okay, there's a lot of people really that helped on open source software development, and also we got some funding, not enough from the EPSRC, and a lot of the research that we do with industry, then they allow us to make things open source. So thank you, and open for questions.